Introduction to Newton's second law. Newton's second law of motion states that the acceleration of an object is directly proportional to the net force acting on it and inversely proportional to its mass. In formula form, where is the net force in newtons, n is the mass, in kilograms, kg is the acceleration, in meters per second squared, m/s squared. This law explains how the motion of an object changes when a force is applied. Key points. 1. Force causes acceleration. If you apply more force, the object accelerates more. The heavier the object, the more force is required to achieve the same acceleration. 2. Units of force. Force is measured in newtons, n. 1 newton is the force needed to accelerate a 1 kilogram mass by 1 meter/s squared. Examples of Newton's second law. 1. Pushing a cart. Suppose you push an empty cart with a force of 20 n, and its mass is 10 kilograms. Using, the cart accelerates at. If the cart is loaded and now has a mass of 40 kilograms, the acceleration decreases as the mass increases. 2. Kicking a football. When you kick a football, it moves because a force is applied. The harder you kick, greater, the faster the ball accelerates. If the ball is heavier, it requires more force to achieve the same acceleration. 3. Driving a car. The engine of a car provides a force to accelerate it. A small car with less mass requires less force to accelerate compared to a heavy truck. That's why trucks need powerful engines to overcome their greater mass. 4. Falling objects. When gravity acts on an object, the force of gravity causes it to accelerate towards the ground at. For example, a 2 kilograms object experiences a gravitational force of 5. Tug of war. If one team pulls with a force of 500 n and the other with 400 n, the net force is F equals 500 to 400 equals 100.